Hello, welcome to a new ProFer video. We are going to continue with the videos. This video, we are going to see functional groups, and in this case, we are going to see groups, acid groups. Come on, let's go with it. I stopped by here, and here you have the cover of ProFer, my cover, and as I told you, we are going to continue with functional groups in chemistry. Organic and also applied with examples you have of drugs or compounds that are of interest. Okay, well, let's go down, and since you have the table, as we saw in a previous video, the cations, the ammonium. In this case, we are going to see the following from where priority is given, which are the carboxylate or sulfonate anions that we now see, that is salts of carboxylate or sulfonate or sulfate salts. Well, now I'm painting it right again. As I said, let's look at carboxylates and sulfonates. These carboxylates are going to appear. They are acidic groups that really, unlike the ammoniums that you have in another video, the ammoniums could be fixed where there are 4 radicals, or they could be labile, where we had a hydrogen that, depending on the pKs, A, and the pH can be ionized or not. Well, in this case, acids always, as long as we make a salt, for example, with a metal I painted here. Positive charge, well, since in equilibrium according to the pKs, A has the acid and the pH. Well, we are going to obtain the ionized or non-ionized form. That is, here the acid is always a form. A salt is a reversible form of an acid. So, but unlike here, it does not have to be reversible, which does happen with this one. Well, the metal that we can have can be different metals. The most typical that we know, because they are sodium, potassium, but they can be others. As for example, cations, a cesium, we can find a magnesium, or also for example with inorganic salts, for example with an ammonium, or be one of these. An ammonium that you have painted here that also produces an ionic bond. Or with this, that salts can also be formed. Okay, let's also see some examples of compounds that have sulfate or sulfonate groups. In this case, I wanted to take the green one. Okay, well, with a group, I don't know why he doesn't take it for me. Let's see. Now, yes, now with a sulfonate group, which would be this, for example, a salt of sulfuric acid, but with a radical, this would be a sulfonate. And the same thing, we can make salts with different contrions, or we can find some sulfonate that would have this structure. Well, obviously there are more examples and more functions. Will we then see any surprises with some salt, with something other than carbon or sulfur, for example with a match? Well, we are going to see examples. And since we are on the topic of functional groups, although I often talk to you about functional groups, I talk to you about pharmacophone groups, etc., within drugs. Well, as I tell you, I'll try. Guide me and not get too involved with functional groups. Well, the first example we see is sodium malparate. This drug I paint here is a derivative, obviously carboxylic, because we have them in salt form, and then it has a chain. A chain of 3 carbons and a chain of another 3 carbons. If we were to name it, it would be very easy. 3R45 would be dopropyl pentanolic acid. You have a very simple structure that what it does is inhibit an enzyme called succinic semialdehyde dehydrogenase. And what it does is increase my levels of GABA, which is an inhibitory neurotransmitter. GABA has many very interesting things, and you will see that. Well, if you watch my pharmaceutical chemistry videos, at least serious, we will talk about gravel as an inhibitory transmitter, because it opens the chloride channels and produces a hyperpolarization of the membranes, which means that drugs such as anxiolytics, hypnotics, anticonvulsants can be used, general anesthetics, local anesthetics. Well, we have many actions and some drugs that we will also see right in this video. Well, one simpler, well, as a functional group. Well, there you have it clearly. No, here we have nothing more or very little. We have a carboxylic group. A carboxylate, it doesn't paint me black. I want to change the color to see if I catch it. If a carboxylic group and simply alkane-alkyl chains has nothing more than a branched structure and nothing, we move on to lauryl sulfate, which has a chain of 12 carbons and a sulfate group. Evidently, these Weil structures are antipathic or amphiphilic. Don't 2, 3, 4, 5, 6, 7, 10, 11, and 12 carbons, which would also be a dodecyl sulfate. What characteristics do they have? Well, they are structures that have a polar zone and an apolar zone. Here we have the functional group, in this case a sulfate. And many of these structures are similar. They can be used for many purposes. For example, they are very similar, or structures to soaps, for example, detergents, etc., and emulsifying surfactants. Well, in this case, the DO of CIR sulfate is used a lot in chromatography and strophoresis. Why? Because it will generate my cells the negative charge. On the one hand, negative charge is equal to negative charge when a given concentration, minimum concentration, is given. Micellar, because as I say, they are used, they form micelles, and they will drag the different compounds and they will separate it. Do we have them, for example, in a chromatography? Chromatography that is a mixture between chromatography and electrophoresis, electroosmotic chromatography that changes Wirth micellar? Well, very interesting. A compound of this type, chloracipathopotassic, I'm going to delete here. Let's see if I can, because if we don't have very good chloracetate, which is a benzodiazepine, a hypnotic, give you another drug. We talked about sodium valproate upstairs, related to GABA, and here we have a benzodiazepine that is also related to the GABAergic receptor, is a GABA coagonist. What it does is that when the benzodiazepines join, they favor the binding of the receptor to its receptor. Therefore, they are going to produce hyperpolarization, has this structure, and chloracetate is characterized by having position 3, which is what you have here, well, by having a salt. Since this compound is a salt, what is it going to do? Well, it is the classic benzodiazepine that is exploited with maxillytics, but in these cases, they are used as hypnotics. Why? Because by having this carboxylyl group, it makes it more polar, that it is eliminated more quickly, with which I give it as a hypnotic to induce sleep, and the next day, I don't wake up with concentrations, I don't wake up asleep, I don't wake up with sedation. Okay, so here you have potassium corazepate. What functional groups would it have? Well, color change. Let's put a blue one. Let's see if they get it right. Well, what would it have? Well, look at it. A chlorine, halogens, 1 year tire, a benzene, 2 years, tires that. Does it belong to the pharmacophore group? Are they important for the activity? And then here, what do we find a measure? Here we have, as a pharmacophore group, a measure very typical of many drugs. Well, if I ever misspell, but well, I'm counting. Amide, the carboxylate group, which is what we have here. This double carbon makes nitrogen, which is this. This is called a hymine. It is a functional group called hymine. Also a very interesting group, and mines are going to be from CHIF-that. They appear in organic chemistry, in pharmaceutical chemistry, etc., etc. Okay, let's go. And I have given you more examples, okay? I have given you a benzyl penicillate. Well, this is a penicillin, of natural origin from the first penicillins. It's a penicillin G that has this structure. It looks around here, okay? To fix you like this would be a side chain of the vensilamide type, the typical pharmacophore group of beta-lactams, cephalosporins, tyramycins, monobactams. What is this cyclic amide, or is it called lactam? Well, the benzyl penicillin G, has this structure and is a compound that is active to us orally. Due to the structure it has, the pH of the stomach is hydrolyzed. So I have to administer it parenterally. Well, it is a penicillin that, as I say, is not acid resistant, not resistant to masses. It is not for use. Spectrum seems like one. A bad penicillin, but please, we must thank it, because thanks to it, people are alive. Because antibiotics have increased life expectancy a lot. So a lot of respect for this penicillin, as I always tell you. Everything is chemistry. Everything is chemistry. And, well, a compound, a molecule, even a group can save your life. Is this worth it? Will you go with my videos? Well, since I'm going to give it, I beat penicillate. I'm going to give it a parenteral route, for example. I'm going to give it an injection, because I have to solubilize it in a way to solubilize it. As you know, I'm already counting. They are making salts. The salt is good. You can play with the contrions, and we can make those salts hydrophilic, or even hypophilic. It's another concept that I'll tell you about in other videos. In this case, for example, we can make benzyl penicillin with benzathine, or we can make it in a salt, for example, Fixu. I'll paint it for you. I wanted to paint it in green rather than in color green. Let's see. Okay, I'll paint it for you. Fix this ionized acid with this. Here would not be potassium if I don't have ammonium, and I'm going to give you procaine. Procaine is a 2-deethylamino ethyl paraminobenzoate. So look, this is a local anesthetic, and here we kill two birds with one stone. On the one hand, we make a more lipophilic salt. What will be retained instead of administration? This is an amino, huh? A primary amino that will be retained instead of administration, and at the same time procaine, as it is an injection that is usually painful. Those of you who are younger, or ask your parents when in the past there were practitioners in all the neighborhoods, because they gave you this injection because there were no oral penicillins and they were very painful, because with procaine, which is a local extension, that pain decreased very well. Ibuprofen plus arginine. Here is an example, as I saw you in the video. If you saw the previous ammonium video here, ibuprofen is given with an arginine, with which a salt will be formed. Well, here I give you first the ibuprofen that would be in the form of carboxylate. And by giving it with arginine, that arginine is an amino acid that will do. Well, it will change the characteristics of ibuprofen. It will solve it much better, and that will make it have greater regional bioavailability. That is, an ibuprofen only has absorption problems and its oral bioavailability. The amount and speed with which A reaches the blood is much, much less than if we give it with arginine, which is simply a basic amino acid. The most basic group of estacitin would be the guanidine that you have here. Therefore, it is the one that forms the salt with the three. Let's see if I paint it correctly, okay? And as I told you, well, this is an amino acid. Well, here you have a carbohydrate with an amino acid. Here I have told you the groups, we are going to put them in black. The functional groups that we find, again, an aromatic ring. We find a chain where we have a very important side chain site. Okay, this measure is even more important than it's a measure that's staichic. This is what is known as the alphabet. It is a beta-lactam, and it is very important for the pharmacophore group. This would be a sulfur with two radicals. We are talking about an ether uncle well, and as we have said, groups, Carlos Chilato is Worthinia ibuprofen. We simply have an alkyl side isobutylene, an aromatic ring, then you have them painted, that is then better painted than how you have them, the figures better painted than how I paint them. But hey, I think a carboxylate looks more or less good. There you have it. And then look at how the salt forms, as I told you, with the guanidine, which is this group that you have here. And then you also have a functional group, a non-ionized silica carb, in this case, and a primary mine typical of amino acids. Okay? Okay. Let's move on to the next black from aerochromote, but I'm going to remove all this from you because it also has a very large structure and we have to clean it. Well, aerochromote black is an indicator of complexometries of volumes with complex formation, for example, widely used to see the hardness of water, the amount of metals such as calcium type, magnesium type, they form complexes with electa. Well, this is an indicator, and see what structure it has. I have given it to you because in this case, it is an indicator of a sulfonic group. I paint it for you. We have a naphthalene that has a sulfonic group in this position, and like any indicator, it is going to have chromophore groups. That is, they absorb ultraviolet visible in the visible, and we are going to have chromophore groups that are conjugated bonds that absorb, as I tell you, that energy. And then we also have ausochromes or electron donor or acceptor groups that favor absorption. In this case, it's a molecule that's also very, very symmetrical. Partly here we have another aromatic child. That's how I paint it, right? Two naphthalenes, okay? And then you have two alcohol groups, two phenol groups. Over here and here we have a nitro group, a very important acceptor group in organic chemistry and in pharmaceutical chemistry as well. Well then, as groups, what do we have a sulfonate that we have here in this form? Sodium sulfonate. For example, the two alcohols phenols, which also have quite acidic hydrogens. That is, they are going to be ionized. And a nitro group and the naphthalenes, this indicator, if we have it as in this form, which is H2, less indicators. Well, it is going to have a color that is a color red wine when it is, keeping the magnesium. Well, if we add electa, what it is going to do, it is going to stay because it has a greater affinity for magnesium, for calcium, and then it removes the indicator of magnesium, with which the indicator, and also what is going to happen to this form that we are going to have. What's going to happen? Well, in this form, it has a blue color in 2 less. Okay, and electa, we could also put it in this group because it is an ethylenamine. Now that the tetracetic count has also come out in salt form, for example, it can be tetrasodium, which is with 3 strong basic medium sodiums, sodium and another. Here you have elected an agent, valuating an agent. Complexing agent, well, we will see it in many places because it is very cool. For example, tetraceutical. Here you have ethylene and amine, and the groups, the 4 acetic groups in the form of tetrasodium tetracetate, for example. Okay, well, we're still going down. Here I have given you some examples, and here you have them very quickly. Sodium valproate, I hope you painted them well, I think so. There you have the carboxylate group. Here you have sodium lauryl sulfate or dolesyl sulfate with that positively charged sulfate group. Okay, here you have chloracetate painted differently, but it's the same, it's a carboxylic group, an imine, amida, 2 aromatic rings, and a very typical chlorine halogen that, well, I almost crossed it out. Very typical of DE, of non-halogen drugs in the aromatic rings. Well, I told you about benzyl penazolate or natural penicillin G. That saves lives. There you have one measure, the site charge, another measure being part of a cycle that is a lactam, the carboxylate group, and a thiodether group. And we have seen some other salt. For example, with procaine, I have told you about ibuprofen with arginine that improves absorption. You have it, I have explained a little. Why does this improve phoral bioavailability? Well, the carboxylate group is arginine, which is a group. A guanidine of alkylene, which is a very basic group, very basic, one of the most basic groups that exist at the biological level, at the drug level, okay? Then we talked about the amino acid, well, an acid group and an amino group. And finally, the black of chromium T has been put on, which had this beautiful, so characteristic structure. It hasn't been spoken, okay, because I ate it. No, I haven't put it on before I put it on directly. Be careful, important dye. I have missed these dyes. These indicators are dyes, azoters. I mean, with the very typical ASO group that I've eaten before, all this conjugation is worth the 2 groups, or HS, the group sulfonic, etc., etc. Well, here you have the ASO group, here you have the sulfonic sulfonate group in salt form, sulfonate and nitro group, and the 2 phenomena. Okay, then be careful that I have eaten, I repeat again, nothing happens, that ASO group, very typical EH. We have that ASO group in many indicators, EH. Okay, here I have put an image where you can clearly see how black Lere chromotech is. When it is joined to magnesium 2 more, it is left has a color, a reddish color, very red wine, and precisely a volumetry due to a compressometry. When electa picks up calcium, water hardness, calcium, magnesium, finally he removes it from the black Lere chromotech that is going to change color and switches to a blue color that you have there, so beautiful. It's very good. Well, to finish this video, we are going to see some examples of other drugs identifying the functional groups. Very interesting drugs. Mesna is an antioxidant agent, an antidote that is used in association with anti-tumor drugs. For example, a cyclophosphamide produces a metabolite called an acrylane. Look, a conjugate aldero with a double bond, which produces hemorrhagic cystitis because at the kidney level, it will attack the biological material. Okay, so Medna is one of the detoxifying agents, an antidote for associated with cyclophosphamide to not produce that hemorrhagic cystitis. That side effect is worth it. What structure does MedDNA have? Because MedDNA is a group, a sulfonic group in salt form, 1 more sodium sulfonate, an ethyl and a Mercato group. This thiol Mercato group is very interesting. We will see drugs with which here what we have is, as I tell you, a thiol group that is going to detoxify and a salt of a sodium sulfonate group. Hence then the name of, if we realize we listed 1, 2 would be a 2. Mercato is a Mercato group as a secondary function. A thiol group, 2 Mercato sodium ethyl sulfonate. Well, is dipyron magnesia worth it? Well, dipyron magnesia is in the world of NSAIDs. Although today it is being seen that it really is a mechanism, it is a little different, and it is also an analgesic and antipyretic drug because it stops fever. Although it is included within NSAIDs, because its mechanism changes a little, and it is more, as I tell you, analgesic and antipyretic that can also be used for other pathologies. But basically with a pyrazolone structure that goes into a little of this type of drug, right? Well, it's got a phenyl, a methyl, and where do we go? If I don't paint it wrong, here we have a tertiary mine and then another methyl mine. And here the group, which in this case I have given you, can be done. You come out with sodium, with potassium, with everything else is fine, but here dipyron magnesia, or the 2-metamizole, which is also known since it can form a salt with magnesium, and since it has a positive 2 charge, since there would be 2 dipyrones for each magnesium. Okay, I'll paint you the astronon for this, because I'm going to erase a little of this. Let's see, clean the page here, okay? And I'll paint you the astronol. Astronol is another beta-lactamic that we have come up with, and that is also very, very beautiful, very curious, because it is a monovactam, but here the sulfonic group appears in the form of a sodium sulfonate salt, is an antibiotic. Over here it has a methyl. Let's see if I paint it backwards. Well, I think I remember. There is this chemistry that is important here, the side chain, a measure, okay? Let's see if it gives me space here for you to see it, okay? Well, I think I can. Here we have this group that has this structure C, or here in the side charge it has another carboxyl group, and here we have a thiazole. That doesn't matter much to me. Okay, I'm going to repaint it because I'm seeing that it doesn't fit me. And I've done more interpage. Okay, it's worth 1 second. And well, since all this is going to serve directly, neither the edicts nor anything, well, if I'm wrong, I'm wrong. Or in this case, if I have to come here more, well, it's better. Well, as I told you, we have the important lactam, we have a methyl, etc. We have the sulfonic group, sodium sulfonate, the sodium afronale, and then the meat at the back that didn't give me space, and I painted. Okay? He's got a measure around here. Then over here they have this group that is very typical of these drugs for different reasons. Here we find another acid group, or a carboxylate, and then what I couldn't fit over here is a thiazole group. Okay? They'll have them over here in a thiazole and with a group to me. Well, I hope you painted it right. I fail in my memory. And then nothing. What functional groups do we find here? Look at you, one measures another. Measure 1 metalactam just like before the sulfonate group sodium. Sulfonate, we find another carboxylate. And what is this group called? This group is 1R or N double bond. Would be an alkyl OSI and mine. Okay, alkyl, OSI and mine. This group is derived from an oxime, that an oxime is OHN double bond. This is a amine with a hydroxyl group called osima. Well, in this case it is a Unoshima derivative of the alkylose and mino type well. And then here we have a thiazole, a tetracyclic structure, and well, we could fit this structure, this group with its caveats, but well, like a thiourea isothiourea derivative, well, nothing. We continue going down to, I have the Fox card left, which is very interesting. It is an antiviral. Used for cytomegalovirus, has also been used for VH, for herpes, etc. It is a polymerase inhibitor, but it does not have the typical structure of modified nucleoside base, but rather polymerases because it resembles one to the structure of pyrophosphates. No, in this case you change the group. Notice, not all the groups are going to be sulfonic groups or carboxylate groups, but here we find a phosphonic group that forms salts with sodium that it would have. 2 groups, and then a carboxylate group. Fix the name, because it could be del, is a phosphonic, a methanoic or phonic phosphono in salt form with these 3 groups. Okay, look at all these salts. What characteristics does it have? What makes it a very, very, very polar compound? a very hydrophilic compound. And obviously orally, it will have more absorption. I think it's 10% only if we give it between 10 and 20. So how's it going to go? Is it going to be given in an injectable? Okay? A perfusion of this compound is going to be put in a dropper, which obviously has to be injectable, but it has some other advantages. For example, that it does not produce resistances with respect to other antivirals, which are evident from polymerases. Okay. Well, I think nothing else for this video. Well, here are the ones we had, the ones I have drawn for you, the mesna, with the thiol group as the functional group, a sodium sulfonate group, the metraminol, the magnesium dipyrone, again with a sulfonic group, with a tertiary amine group. And we haven't talked about this group here, but it's an amide with another nitrogen. It's a hydrazine. If only I had. We would be NH-NH. This is a hydrazine, but having an amide, well, it is a hydrazide. Okay, it is a hydrazide type group. And then the trunam, well, we have already commented on it, although it is painted differently here. Sulfonic group, cyclic friend, or lactam, a canatrolamide, a carboxylate group, an alkyloxy and amino group as an analog of an oxime, and then a thirazole that has an amino. Hey, but everything together would act quite similar, although not completely, because it is part of the cycle, well, like one if it were an isothiourea. If a tihureas is like that, if a urea is like that, well, an isothiourea is what it would have. N, whatever it was winnate, whatever it was worth. Well, this is video. I hope you liked it, okay? And nothing, subscribe, like me please, and let's continue doing, well, more videos. Okay, here I have left my phone number for anyone who wants to contribute and help, because these videos are free. Well, there you have that contribution. Okay, well, nothing. What I said, thank you very much, and until the next video.